Hello students, here is a second lecture. In this video, you can learn how to solve problems on limit. First, let us learn what is indeterminate form. Indeterminate forms are those forms which do not have a definite value, such as 0 by 0, infinity by infinity, 0 into infinity, infinity minus infinity, 0 to the power 0, infinity to the power 0, 1 to the power infinity. The forms like 0 by 0 and infinity by infinity can be solved by using L'Hospital rule. That is, to evaluate the limit f of x by g of x as x tends to a, and if f of a is equal to g of a is equal to 0, then the above form becomes 0 by 0. In that case, the rule says evaluate the limit f dash of x by g dash of x as x tends to a. What if f dash of a and g dash of a are equal to 0? Then the forms again 0 by 0, which is an indeterminate form. Find limit f double dash of x by g double dash of x as x tends to a. This is how it follows. If f of a is equal to g of a is equal to 0, then limit f of x by g of x as x tends to a can be expanded using Taylor series method about the point x is equal to a. That is, limit x tends to a, Taylor series expansion of f of x is f of a plus x minus a into f dash of a plus x minus a whole square by 2 factorial into f double dash of a and so on, divided by g of a plus x minus a into g dash of a plus x minus a whole square by 2 factorial into g double dash of a and so on. Observe that f of a and g of a are equal to 0. Now take x minus a common both from the numerator and denominator so that the above equation reduces to the form limit x tends to a, f dash of a plus x minus a by 2 factorial into f double dash of a plus x minus a whole square by 3 factorial into f triple dash of a and so on, divided by g dash of a plus x minus a by 2 factorial into g double dash of a plus x minus a whole square by 3 factorial into g triple dash of a and so on. Now by applying the limit, you will get the right hand side as f dash of a by g dash of a. Similarly, if f dash of a and g dash of a are equal to 0, then repeat the above procedure by taking x minus a common from the previous step. But however, we will restrict ourselves to the problems of the following indeterminate form, that is 1 to the power infinity, infinity to the power 0, 0 to the power 0. First problem. Find limit of sin x power tan x as x tending to pi by 2. Just apply the limit so that it is of the form 1 to the power infinity. Such kind of limits can be solved by the following method. Let k be equal to limit x tending to pi by 2 sin x power tan x. Taking log on both the sides, log k is equal to limit x tending to pi by 2 log of sin x power tan x, which is of the form log m to the power n, which is nothing but n into log m. I can write it as limit x tending to pi by 2 tan x into log of sin x. But tan x can be written as 1 by cot x. Therefore, log k is equal to limit x tends to pi by 2 log of sin x by cot x. Now apply the limit and observe the form. It is 0 by 0. So, the main intention to take log on both the sides is to reduce the indeterminate form to either 0 by 0 or infinity by infinity. Now apply the L'Hospital rule, that is, differentiate the numerator and denominator with respect to x. The above limit reduces to the form limit x tending to pi by 2 cos x by sin x divided by minus cosecant square x. Apply the limit and observe that cos pi by 2 is equal to 0 and sin pi by 2 cosecant square pi by 2 is equal to 1. So that log k is equal to 0, which implies k is equal to e to the power 0, that is 1. Next problem. Find limit of sin x by x whole raised to 1 by x square as x tending to 0. The first step is to apply the limit, and limit x tending to 0 sin x by x is 1, so that you will get 1 to the power infinity form. Let k is equal to limit x tending to 0 sin x by x whole raised to 1 by x square. Taking log on both the sides, that is, log k is equal to limit x tending to 0 1 by x square into log of sin x by x. But log a by b is log a minus log b. Therefore, log k is equal to limit x tending to 0 log of sin x minus log x divided by x square. Now apply the limit. Since sin 0 is 0, so numerator you will get log 0 minus log 0 divided by denominator 0 square, that is 0 by 0 form. So you can evaluate this limit by using L'Hospital rule. By the L'Hospital rule, differentiate numerator as well as denominator with respect to x and then apply the limit. Therefore, log k is equal to limit x tending to 0. Differentiation of log sin x is 1 by sin x into cos x minus derivative of log x is 1 by x divided by derivative of x square is 2x. Or log k is equal to limit x tending to 0 x into cos x minus sin x divided by 2x into x sin x. But in order to reduce the limit, multiply and divide by x, and we know that limit x tending to 0 sin x by x is 1. Therefore, the above becomes limit x tending to 0 x into cos x minus sin x divided by 2x cube. Now apply the limit. Again you will get 0 by 0 form. So again you can apply L'Hospital rule. Therefore, log k is equal to limit x tending to 0. Differentiation of x into cos x is cos x minus x into sin x minus derivative of sin x is cos x divided by differentiation of 2x cube is 6x square, which is equal to limit extending to 0 minus sin x by 6x, that is equal to minus 1 by 6, and hence k is equal to e to the power minus 1 by 6. Next problem. Find limit of 2 minus x by a whole raised to tan of pi x by 2a as extending to a. By applying the limit, you will get 1 to the power infinity form. So take k is equal to limit extends to a 2 minus x by a whole raised to tan of pi x by 2a. Now take log on both the sides, so that you will get log k is equal to limit extending to a tan of pi x by 2a into log of 2 minus x by a, which can be written as limit extending to a log of 2 minus x by a divided by cot of pi x by 2a. Now apply the limit. When you apply the limit, you will get numerator is equal to log 1, which is equal to 0, and denominator is equal to cot pi by 2, which is equal to 0. So now it is of the form 0 by 0. Now you can apply L'Hospital rule. That is, differentiate both the numerator as well as the denominator and then apply the limit. So differentiation of log of 2 minus x by a is 1 divided by 2 minus x by a into differentiation of 2 minus x by a is minus 1 by a divided by differentiation of cot of pi x by 2a is minus cosecant square of pi x by 2a into derivative of pi x by 2a is pi by 2a. After applying the limit, you will get log k is equal to 2 by pi, and hence k is equal to e to the power 2 by pi. Next problem. Find limit of a to the power x plus b to the power x plus c to the power x divided by 3 whole raised to 1 by x as extending to 0. By applying the limit, you will get it as 1 to the power infinity form. So take k is equal to limit extending to 0 a to the power x plus b to the power x plus c to the power x divided by 3 whole raised to 1 by x. Now take log on both the sides, so that log k is equal to limit extending to 0 1 by x into log of a power x plus b power x plus c power x divided by 3, which is equal to limit extending to 0 log of a power x plus b power x plus c power x minus log 3 divided by x. By applying the limit, you will get 0 by 0 form. So we can apply L'Hospital rule. That is, limit extending to 0, derivative of log of a power x plus b power x plus c power x is 1 by a power x plus b power x plus c power x into a power x into log a plus b power x into log b plus c power x into log c minus derivative of log 3 is 0 divided by derivative of x is 1. And by applying the limit, we will get log k is equal to 1 by 3 into log of ABC, or log of cube root of ABC. Hence, k is equal to e to the power log of cube root of ABC, which is equal to cube root of ABC. Next problem. Find limit of 1 plus sin x whole power cot x as x tending to 0. After substituting the limit, you will get 1 to the power infinity form. So, take k is equal to limit x tending to 0, 1 plus sin x whole power cot x. Now take log on both the sides. That is, log k is equal to limit x tending to 0 cot x into log of 1 plus sin x, or limit x tending to 0 log of 1 plus sin x divided by tan x, which is in 0 by 0 form. So by L'Hospital rule, log k becomes limit x tending to 0 1 by 1 plus sin x into cos x divided by secant square x. After applying the limit, you will get log k is equal to 1, which implies k is equal to e to the power 1, that is e. Next one. Find limit of a power x plus x whole power 1 by x as x tending to 0. When x is tending to 0, a power x plus x is tending to 1 and 1 by x is tending to infinity. Therefore, given limit is in 1 by infinity form. So take k is equal to limit x tending to 0 a power x plus x whole power 1 by x. Now take log on both the sides. That is, log k is equal to limit x tending to 0 log of a power x plus x divided by x, which is in 0 by 0 form. So by L'Hospital rule, log k is equal to limit x tending to 0. Derivative of log of a power x plus x is 1 by a power x plus x into a power x into log a plus 1 divided by derivative of x is 1, which is equal to log a plus 1. But 1 can be written as log e. Therefore, log k is equal to log of e into a, which implies k is equal to e into a. Next problem. Find limit of secant x power cot x as x tending to pi by 2. First apply the limit. When x is tending to pi by 2, secant x is tending to infinity and cot x is tending to 0. So you will get infinity power 0 form. In this case also, take k is equal to limit x tending to pi by 2 secant x power cot x. Now take log on both the sides. That is, log k is equal to limit x tending to pi by 2 cot x into log of secant x, or limit x tending to pi by 2 log of secant x divided by tan x. Now apply the limit. Secant pi by 2 is infinity, so numerator you will get log infinity, which is infinity. Tan pi by 2 is also infinity. So infinity by infinity form. Since we know that if we get the limit as 0 by 0 or infinity by infinity, then we can use L'Hospital rule to evaluate that limit. So by the rule, log k becomes limit extending to pi by 2 1 by secant x into tan x divided by secant square x, which is equal to limit extending to pi by 2 tan x by secant square x. If you apply the limits, again you will get infinity by infinity form. So to avoid the further differentiation, let me rewrite tan x as sin x by cos x and secant square x as secant x into secant x. But cos x into secant x is 1 and 1 by secant x is cos x. Therefore, log k becomes limit x tending to pi by 2 sin x into cos x. Now apply the limit. Since cos pi by 2 is 0, therefore log k becomes 0. Hence, k is equal to e to the power 0, which is equal to 1. Next problem. Find limit of cot x power 1 by log x as extending to 0. By applying the limit, as extending to 0, cot x and log x is tending to infinity, so that 1 by log x is tending to 0. So the given limit is of the form infinity power 0. So take k is equal to limit extending to 0 cot x power 1 by log x. Now take log on both the sides, that is log k is equal to limit extending to 0 log of cot x by log x, which is of the form infinity by infinity. So apply L'Hospital rule. Derivative of log of cot x is 1 by cot x into minus cosecant square x, and derivative of log x is 1 by x. Therefore log k is equal to limit extending to 0 minus cosecant square x by cot x divided by 1 by x. But cosecant square x I can write it as 1 by sin square x and cot x as cos x by sin x. So that you will get log k is equal to limit extending to 0 minus x by sin x into cos x, or limit extending to 0 minus 1 by sin x by x into cos x. But limit extending to 0 sin x by x is 1. Therefore, you will get log k is equal to minus 1, or k is equal to e to the power minus 1, that is 1 by e. Next problem. Find limit of tan x power tan 2x as extending to pi by 2. Since tan pi by 2 is infinity and tan 2 pi by 2, that is tan pi, is equal to 0. Therefore, after applying the limit, you will get infinity power 0 form. So take k is equal to limit extending to pi by 2 tan x power tan 2x. Now take log on both the sides. We will get log k is equal to limit extending to pi by 2 tan 2x into log of tan x, or limit extending to pi by 2 log of tan x by cot 2x, which is of the form infinity by infinity. So by L'Hospital rule, we will get log k is equal to limit extending to pi by 2 1 by tan x into secant square x divided by minus cosecant square 2x into 2, or limit extending to pi by 2 minus sin square 2x by 2 sin x into cos x. But 2 sin x into cos x is sin 2x. Therefore, log k is equal to limit extending to pi by 2 minus sin square 2x by sin 2x, which is equal to limit extending to pi by 2 minus sin 2x. Therefore, after applying the limit, you will get log k is equal to 0, or k is equal to e to the power 0, which is equal to 1. Next one. Find limit of cos x power pi by 2 minus x as extending to pi by 2. As x is tending to pi by 2, cos x and pi by 2 minus x is tending to 0. So the given limit will be of the form 0 to the power 0. So take k is equal to limit extending to pi by 2 cos x power pi by 2 minus x. Now take log on both the sides, that is log k is equal to limit extending to pi by 2 minus x into log of cos x, or I can write it as limit extending to pi by 2 log of cos x divided by 1 by pi by 2 minus x. But log of cos of pi by 2 is log 0, that is infinity, and 1 by 0 is also infinity. So that we will get it as infinity by infinity form. Therefore, by L'Hospital rule, log k is equal to limit extending to pi by 2. Derivative of log of cos x is 1 by cos x into minus sin x divided by derivative of 1 by pi by 2 minus x is minus 1 by pi by 2 minus x whole square into minus 1. That is minus tan x divided by 1 by pi by 2 minus x whole square, which is equal to limit extending to pi by 2 minus pi by 2 minus x whole square divided by cot x. Now apply the limit. We will get 0 by 0 form. So again go for L'Hospital rule. That is, derivative of pi by 2 minus x whole square is 2 into pi by 2 minus x into minus 1. And derivative of cot x is minus cosecant square x. Therefore, log k is equal to minus 2 into pi by 2 minus x by cosecant square x. So as the limit x is tending to pi by 2, log k will be equal to 0. Therefore, k is equal to e to the power 0, which is equal to 1. Last problem. Find limit of 1 minus x square power 1 by log of 1 minus x as extending to 1, which is of the form 0 to the power 0. So take k is equal to limit extending to 1, 1 minus x square power 1 by log of 1 minus x. By taking log on both the sides, we will get log k is equal to limit extending to 1, log of 1 minus x square by log of 1 minus x. By applying the limit, we will get infinity by infinity form. Therefore, by L'Hospital rule, log k is equal to limit extending to 1, 1 by 1 minus x square into minus 2x divided by 1 by 1 minus x into minus 1. But 1 minus x square can be written as 1 minus x into 1 plus x. Therefore, log k is equal to limit extending to 1, 2x by 1 plus x. As x is tending to 1, log k will be equal to 1, which implies k is equal to e.